making different types of gaskets. In preparation for making a gasket, be sure to keep a written record of the dimensions available for confirmation at any time during the process. Include all 3 dimensions to ensure a complete set. These measurements are for the gasket on the top of the oil reservoir. The material used to make gaskets is a cork composite, specifically developed for the transformer and distribution industry. To make gaskets that have a large inner and outer diameter, the following technique should be used.
Okay, the gasket that I'm going to be making is 20.5 inches by 17 inches, and it'll be 3/16 of an inch thick. So what I'm going to do now is I'm just going to cut a section slightly larger than the 27.5 that I need. So I will measure this out here. I'm going to go to approximately here. I'll make it 22 inches right there, and then the depth.
The material is delivered in sheets with a specific thickness.
So that's actually the cut. This is the section that I'll be using right here. Okay, so I'll just take that off. I'm going to take my utility knife. I'm going to cut that piece. Like that. And then I'm going to cut this piece here. And across here. Okay, so there's our piece. There's our piece, approximately 22 inches in square. Okay, this machine is just called a circle cutter. It's also used for cutting sheet metal into circles, and it can also cut corporine gaskets into circles. The outer diameter of the gasket that we're going to be cutting right now is 21.5 inches, and that's right there. Okay. It can do any size up to 48 inches in diameter. Okay, just loosen it off, and I'm going to slide this measuring device. I got to be back there. The measuring device comes back. Yep. Okay, this edge right here is the pointer that goes to the exact measurement that you want. 1.5 inches right there, and I'm locking it into place. Okay, now I'm going to take this board. I'm going to fit this in here. Just like this. It just balances there. Okay. Okay. Now you see the blade is covering the entire surface. Okay. Okay. The motor's running. Okay, now I'm going to lower the blade into the corprine, and it'll start spinning. Okay, and then I'm going to take my pen at this point before I cut through the corprine. I'm going to take the pen and just make a circle right here so I will know exactly where center of this piece is at all times. Okay, there's a mark there now. Now I'm just going to cut slowly, cut through the corprine. Starting to cut through now. And there's our gasket. I can just take this out of here now, raise the blade up, pull this out like this, and you can actually pull. There's your actual, that's your outer diameter right now of the gasket that you're going to be making, and you can see here that it's exactly 20, just shy of 20 and a half inches. Okay. That's where it sits, right there. Then you can just double check to make sure that you've got a good centered all the way around. Okay. And now you do your cut for your inner diameter. And there's your gasket. And this is your actual, your gasket. Okay, I'm just going to put this together here.
For small gaskets, a special punch is used.
Okay, then I'm going to take this blade here for this punch, put it in here. Okay. The center first, and then you have to do the outside.
Oh, I see. It makes it all at once.
And it's going to, there's your actual, you can see the size of the gasket right there. Right, for this part it's not an issue. And then you're just going to put a board underneath your corprine. It's 1/16 inch thick. And you just take this, you take a mallet, and you just literally punch it out. Okay, there's your gasket. You take this off, and there's your actual gasket right there.
Hold real still. Really still.
Okay, and that's the original, and that's the new.
Steady.
That's the new one. I just take this and I match it up to the blade that I need, and that's then I know exactly what size I have to make it.
In order to determine the size of the
Okay.
punch that's required, simply place
And
the
then the
old
center
gasket on top
do
of
the
the
same
circular
thing.
cutting edge of various punches. First, determine the punch that matches the outer diameter. Use the same process for determining the size of the punch that will cut the inner diameter. The punches are kept together in a kit, along with the chisel-like tool onto which the punches are mounted.
Okay. It's 3 3/4 inches on the OD. And it's 1 7/8 on the ID.
Twist it to the back.
Make it 1 3/4 on the ID as well.
To make circular gaskets less than 13 inches in diameter, the following process can be used.
Okay, this is a circle cutter. It's just manual. The outer diameters and the inner diameters can be adjusted by the sizes on the underneath part, the bottom part here. So I can go 2-inch OD, 2-inch ID, 5-inch. I can go all the way up to 13 inches. Okay, so I'm going to adjust it for 3 3/4. So I just slide this.
Really steady.
Okay.
And go ahead.
Okay, I slide it to 3 3/4. I lock it in place. Okay.
Okay.
Now I'm going to take this pin.
Okay, go ahead.
I'm going to insert the pin through the corprine. Right here. It just came through. And then I'm going to place the pin in this little center device here. Like that. Now there's a blade right here, which is going to cut my circle for me. And all I have to do is spin it around.
Nice and slowly.
Yep. That's my circle right there. That's my outer diameter. 1 3/4. Then I reinsert this into there. Place it back in the hole. And then I just do this cut. And there,
Go ahead.
okay. So what I'm going to do is I'm going to trace those 4 holes. They will be punched out. Okay. Okay, and then I'm just going to take the punch, line it up with the holes I've traced. There's one.
This time hold the punch a little higher so I can see your hands not blocking it.
Okay, like that.
Yeah, sure.
Okay. Okay. And there we have our
Nice and steady.
Refurbishing the oil reservoir tank. When refurbishing the oil reservoir tank, begin by cleaning out any debris that may have accumulated in the heads of the hex screws that hold the level gauge to the reservoir tank. Use a small screwdriver that will fit inside the hole in the head of the hex screws. A mallet and an impact driver should be on hand for the type of work that will be performed. The impact driver is used to loosen bolts or screws that are seized. When it is hit with the mallet, it delivers a strong rotational downward force. The spring-loaded action inside the driver permits the direction of delivered force to be reversed if required. In this case, the screw is turned to the left when the mallet makes contact with the impact driver. When the screw has been loosened, the socket on the driver can be removed and then attached to a regular ratchet. The ratchet can then be used to remove the screw entirely.
regular ratchet. If you want to see that. And then we can extract it. Okay. There it is.
Once unscrewed, pull it out of the hole and safely store it along with the washer.
Okay.
Continue loosening the screws and removing them.
Well, from what I can see right now, it looks like this Allen screw is worn out on the inside. It looks like it's stripped. I don't think I'm going to be able to. Use this tool. I'm going to try to force this in.
In some cases, the hex screw may be totally stripped, and it may not be possible to remove it using the impact driver. First, try inserting the ratchet bit and tapping it a few times with the mallet. If it seems tight, then reattach the ratchet wrench to the bit and try turning it counterclockwise. In this case, the screw can be successfully removed this way.
Yeah, it's corrosion, 40 years of...
When a screw is completely stripped or corroded to the point where it is not possible to remove this way. One alternative would be to drill the head of the screw off, using a drill bit the size of the screw head, and then, after removing the other 3 screws, remove the level gauge. At that point, the remainder of the corroded screw would be exposed enough to be able to grasp it with vice grips and remove it.
There it is. Okay, that should be it. There it is.
When the last screw has been removed, ensure that the gauge will remain seated before you take your hand away to store the screw. Using a small screwdriver, pry the gauge out from the cavity in which it is seated. Through the window on the front of the gauge, the yellow indicator arm is clearly visible, along with the numbers on the scale indicating minus 10 degrees centigrade, plus 20 degrees centigrade, and plus 75 degrees centigrade. The scale is for temperature simply because the volume of oil in the bushing is directly related to its temperature. The higher the temperature of the oil, the more volume it takes up. When a bushing is refilled with oil, it is filled to the 20-degree level, which is considered to be the normal level. The paint corrosion is clearly visible on the indicator arm. The principle of operation is based on magnetism. There is a magnet located behind the indicator arm that is attracted to metal. Here we can see the indicator arm move in relation to the movement of the metal wrench handle. The same thing happens inside the reservoir tank when the bushing is in normal operation. By manually moving the metal arm of the float that sits on top of the oil inside the tank, the magnet can detect its movement right through the tank because the tank is made of aluminum, also a type of metal.
Due to the fact that this is aluminum, this can is aluminum, so the steel that's used on the float will operate this magnet right through the aluminum. Okay, so I can actually place it back in here and do this.
What are you doing inside with your hand?
I'm moving the float up and down inside, and it just shows you how the magnetism is going right through the aluminum to the gauge.
On the top of the oil reservoir tank, there is still some residual gasket material remaining from the gasket that was seated under the collar below the top flange on the conductor core at the top of the bushing. The dimensions of the gasket must be determined so that a new one can be made and reinstalled. The OD, or outer diameter, will be measured first. The ID, or inner diameter, will be measured after that. The thickness of the gasket will also be determined based on the material from the previous gasket that still remains.
What I do is I measure with the tape measure across.
Using a tape measure, span the length of the outer diameter of the previous
exactly
gasket.
8 inches across on the outer diameter.
Repeat the same process to measure the inner diameter.
Then I'm measuring the inner diameter, and I'm measuring exactly hang on a second here. 6 3/4. across for the inner diameter. And then I'm just going to determine the thickness of the gasket that I require.
To determine the thickness, measure the depth of the channel that the gasket is seated in and add an additional 33%. The additional percentage factor is based on what is considered to be the average amount of compression that will occur over time. This means that when the bushing is reassembled and the collar is installed on the top of the new gasket, 33% of the thickness will be available for compression to create a proper seal. Shown here is a 1/8 inch thick gasket that has the 33% overage in thickness available to be compressed, and this will be very suitable for this application.
And just to see, you can see that there's an edge there.
After the required measurements have been taken, removing the debris and corrosion is the next step in the refurbishment process. In order to clean off the debris, it is imperative to wear a half-face air purifying respirator with the appropriate gas vapor cartridges, as well as safety glasses. Using an electric hand sander, sand off as much debris as possible from the outside of the oil reservoir tank. Using a small pneumatic drill with the appropriate attachment, begin grinding the remaining debris that is too small to remove with a chisel from the underside of the reservoir tank. Continue grinding off paint and debris from the top of the tank. Using a small chisel in conjunction with a hammer or mallet, begin removing remnants of the previous gasket in the channel where it was seated. Remove any debris inside the screw holes by directing short blasts of compressed air into the holes. Again, using a small pneumatic drill with the appropriate attachment, begin grinding the remaining debris that is too small to remove with a chisel from the inner and outer edges of the channel where the gasket was seated. Spray the top of the tank with isopropyl alcohol, and then, with a cloth, wipe away any particulate matter that may have gotten into any of the crevices. Spray and wipe the sides of the tank in the same way. Begin repainting the tank, starting at the top and from beyond the outer diameter of the channel in which the gasket will be placed to the outer edge of the flat surface that the terminal rests on. The paint to use is called Glyptol, which is a dielectric paint that is specifically for use on parts that make direct contact with or will go inside a transformer. A primer coat is not necessary for this area of the tank. For the side of the tank, standard gray paint is used since there is no direct contact with the transformer, and a dielectric paint is not required. The area that is set back on the side of the tank and where the level gauge display will be inserted should be coated with a water-based primer only. Apply a very small amount of gasket adhesive inside the center of the channel where the gasket will be seated.
Put some gasket adhesive around here. A very small amount of it. I'm going to just take this gasket, place it in here.
Place the gasket in the channel, pressing firmly all around the circumference to make sure that it is seated properly. Pay close attention to any areas that are raised. The gasket must remain flat all the way around inside the channel for there to be an effective seal. The purpose of a gasket is to fill the space between two mating surfaces.
Okay, I think that's about it there. Now we'll just let that glue set up a little bit. Okay.
Place the level gauge on a sheet of oil-absorbent material and begin removing the screws on the reverse side.
Too big. This one.
Make sure that all of the screws are stored safely and accounted for as they are being removed. There may be some screws that are significantly corroded and cannot be removed using only a screwdriver. In order to loosen the screws, briefly heat them with an acetylene torch. It is imperative to wear a half-face air purifying respirator with the appropriate gas vapor cartridges as well as safety glasses when using the torch. Make sure that before using the torch, the level gauge is moved away from the underlying sheet of oil-absorbent material that it rests on. Apply heat directly to the top of the screws as well as the area on the side of the gauge so that the entire length of the screw is heated. When finished heating, try moving the head of the screw forwards and backwards to loosen it. In some cases, the screw head may shear off completely. To avoid a serious burn, be careful not to touch the screws with bare fingers.
These screws will be hot. Don't grab them with your finger. That glass should pop out now.
Remove the back of the gauge and set it face up on the underlying sheet. The faceplate is on the reverse side and shows the scale. Remove the indicator needle.
There's the indicator, the needle. Put it back where it belongs.
Place the indicator needle back onto the pin in the center of the faceplate.
Now back to this.
Remove the 1/16 inch coroprene gasket. This is a medium firm gasket material manufactured by Armstrong Cork Company. It is a cork polychloroprene composite. Pop out the glass window by pushing up from the opposite side. Set the window on the underlying sheet. Remove another gasket, identical to the first one, from the area around where the window was seated.
It's going to come out. Should come out fairly nice, which it is. It'll be replaced as well.
The screws that remain in the frame of the level gauge will now have to be removed using the appropriate equipment located in the machine shop. The faceplate of the gauge will have to be sandblasted in order to remove all of the corrosion on the face of the plate. During the sandblasting process, the existing numbers that are shown on the scale will be lost. In order to make sure the 3 level markers are in the correct location after refurbishing, take a straight edge from the pivot point of the needle and align it with the existing level marks. Etch a temporary mark into the edge of the faceplate where each existing mark is. The temporary marks will not be affected by the sandblasting. Stickers will be placed on to indicate the levels after the faceplate has been repainted.
That's it. Now I can sandblast it, and I have 3 reference points to the pivot point of the needle. So I can put the stickers back on to indicate the levels.
Place the frame and the faceplate of the level gauge into the sandblaster compartment. Using the glove and sprayer nozzle, blast the components to remove all previous coatings. The red paint on the front of the faceplate must be completely removed. However, the etch marks on the frame will remain as reference points. Remove the old paint from the front of the frame of the level gauge and also from the sides. After sandblasting, support the frame on 3 large bolts and apply regular gray paint to the entire surface. The needle and the faceplate must also be coated with regular gray paint.
It was temperatures. Yeah, it was like... Yes, the temperatures are related actually to the oil inside. Oh, absolutely. 20 degrees Celsius was, yeah. That's the oil level. 20 degrees is the standard that everybody wants.
Measuring and cleaning the bottom porcelain insulator. When the bushing is in operation, the space between the lower flange of the conductor core and the bottom porcelain insulator is filled with a gasket that creates a seal. Measurements must be taken in order to replace the old gasket with a new one having the exact same size. Begin by measuring the OD or outer diameter for the new gasket by spanning a tape measure across the center of the porcelain. When the bottom porcelain was removed, it was placed on the floor upside down. In this case, the measurement is 10.5 inches. Measure the ID or inner diameter by spanning a tape measure across the center of the hole in the middle. In this case, the measurement is 6 inches. For this gasket, the entire surface of the lower rim around the porcelain needs to be covered, and by taking OD from the outside edge of the porcelain and the ID from the outside edge of the hole, there will be adequate coverage on the top.
Okay.
Choke the other end of the sling that's already attached under and around the next lowest shed.
Okay. Just take it west a little bit. Okay. Perfect. Very good.
And hoist the unit to just above eye level. Looking up at the unit, it's easy to see the remains of the original gasket that was filling in the space between the top of the porcelain and the bottom of the ground sleeve. Due to immense pressure over a long period of time, the gasket has been squeezed to the point where it expanded well beyond the edge of the joint. To take an accurate measurement, it will be necessary to remove the compressed and expanded portion with a knife so that the dimension from two opposite edges can be determined. The same procedure will be repeated to measure between the inside edges.
That side's clean, so I'll do it like that.
In this case, the OD, or outer diameter, is 20.5 inches. The ID, or inner diameter, is 17 inches.
And it's going to be 20 and a half inches across, OD, the outer diameter, 20 and a half. And the ID, the inner diameter, is going to be 17 inches.
Lower the porcelain unit to the floor so that it rests horizontally on plywood boards draped with oil-absorbent sheets. Remove the sling from the hoist hook. Use a chisel to remove all of the old gasket material that has adhered to the top rim of the porcelain. When scraping, grip the unit tightly to make sure that the unit doesn't roll off the plywood onto the floor. When finished scraping, begin brushing the area using a pneumatic drill equipped with a circular metal brush attachment. The brush attachment should be about 6 inches in diameter. Use the brush in both a crosswise and lengthwise motion in relation to the rim on the unit. It is imperative to wear a half-face air purifying respirator with the appropriate gas vapor cartridges, as well as safety glasses when using the drill to remove debris. Remove as much debris as possible using the brush. Repeat the same set of procedures to remove the old gasket material from the other end of the porcelain unit. In order to wipe clean the areas that have been scraped and brushed, spray first with isopropyl alcohol, which is stored in the flammable liquid storage cabinet. Before using the solution, it is important to read the label for safety instructions. Spray all around and inside of the porcelain at the bottom end. Spray all around and inside of the porcelain at the top end. It is imperative to wear a half-face air purifying respirator with the appropriate gas vapor cartridges, as well as safety glasses, when spraying and wiping with isopropyl alcohol. Wipe as clean as possible using lint-free cloths. Raise the porcelain unit back to an upright position, with the larger bottom portion resting on clean, oil-absorbent sheets draped over plywood. Leave a cloth in the top opening to signify the unit has been cleaned and to prevent debris from falling in. Measuring and cleaning the upper porcelain insulator. After measuring and cleaning the porcelain on the bottom half of the bushing, the same procedures should be performed on the upper half. Since the upper porcelain insulator is seated upright in a service well, use the rolling warehouse ladder equipped with handrails and with the locking mechanism activated to take measurements for replacing the gasket at the top. Using a knife, remove the compressed and expanded portion of the old gasket so that the dimension from two opposite edges can be determined. Proceed as with the bottom porcelain to measure the OD or outer diameter and the ID or inner diameter. After the measurements for the gasket have been taken, use a chisel to remove all of the old gasket material that has adhered to the top rim of the porcelain. It is imperative to wear a half-face air-purifying respirator with the appropriate gas vapor cartridges as well as safety glasses when generating airborne particulates. Attach the slings that are choked around the porcelain to the hoist hook and slowly raise the unit to just above eye level.
How's that? A very basic.
Begin removing the old gasket material using a scraper while grasping it firmly with the other hand.
I'm gonna get some gloves myself.
Continue scraping to remove as much of the old adhered material as possible.
Isn't that what you just did?
Raise the unit and then lower it again to rest on a platform equipped with wooden slats, on which the porcelain can rest while being serviced. Use a pneumatic drill with a wire brush attachment to remove the remaining pieces of adhered gasket material. Cleaning and painting the terminal. Use a screwdriver to clean out some of the larger pieces of debris in the threads at the top of the terminal.
Just cleaning out some of the cement that's around the threads there before he buffs it.
Use a pneumatic drill equipped with the appropriate wire brush attachment to remove smaller pieces of debris that have lodged in between the threads and are not easily removed. Scour the threads using a Scotch-Brite type general-purpose scouring pad. Polish the threads using a pneumatic drill equipped with a flat wire brush attachment.
Okay.
When satisfied that the threads have been cleaned as much as possible using mechanical means, spray them with isopropyl alcohol and scour again with a Scotch-Brite type general-purpose scouring pad. Before beginning to sand the paint off the surface of the terminal, cover the threads on the end with tape to protect them from the dust that will be generated.
It's all show.
Use a pneumatic handheld sander with the appropriate sandpaper on the attachment to remove as much of the old paint as possible. Turn the terminal on its side and using a small pneumatic hand drill with the appropriate attachment, remove debris that has adhered to the bottom metal rim. When all the debris has been removed, polish the bottom using a lint-free cloth. Paint the surface with the terminal with the dielectric paint Gliptol.
Okay.
Measuring the bushing while outside of the oil tank. During the time that the upper and lower portions of the bushing have been refurbished, the core of the bushing with the main insulation has been stored, submerged in oil, in order to protect it from exposure to air. Connect the end of the sling that was tied off to the side of the oil tank to the hoist hook. Slowly raise the hook to put tension on the sling, being careful not to let the slack drop down into the oil in the tank. Very slowly lift the bottom of the bushing off the floor of the tank to let it gravitate back to a natural position toward the center. Slowly begin lifting the bushing up and out of the tank. During the lifting process, the oil on the paper slowly cascades back down the surface of the brown insulation paper from one concentric ring to another. The increasing diameter of the rings is designed to provide the bushing with maximum insulation capacitance. Raise the bushing to a height where the large flange above the ground sleeve is just above the top of the oil tank. Calipers will be used to measure the outer and inner diameter of the gasket that will be installed on the top of the upper flange that will be screwed into the top of the conductor core. Open the calipers and place the tips in a position to measure the OD, or outer diameter, of the channel on the surface of the flange where the gasket will be placed.
I'm measuring the outer diameter now where the gasket is going to be placed in this flange here. So that'll be the OD there.
Remove the calipers, being careful to maintain the same gap between the tips, and place them on a bench so that the tips are facing toward you. Using a tape measure, determine what the outer diameter is. In this case, the OD is 21 inches.
Outer diameter, and that's going to go from there to there approximately. And I will Okay, now I'm going to measure that. The inner diameter of this gasket will be 16 5/8. 16 inches 5/8.
When finished taking measurements for the gasket, slowly lower the bushing back into the oil tank. Refurbishing the compression system. When the compression system was lifted off the conductor core, it was seated directly on the upper porcelain insulator with a gasket in between to fill the space and create a seal. Remnants of the old gasket must now be removed so that a new one can be installed in its place. After turning the system on its side as it sits on the workbench, insert a lint-free cloth inside the hole that accommodates the conductor core. The inserted cloth will prevent any debris from entering the hole. In order to clean off the debris, it is imperative to wear a half-face air-purifying respirator with the appropriate gas vapor cartridges, as well as safety glasses. Using a hammer and chisel, begin scraping off the old gasket material that adheres to the metal. Scrape off as many of the larger particles as possible. Using a small pneumatic drill with the appropriate attachment, begin grinding the remaining debris that is too small to remove with a chisel. During the grinding process, use short blasts of compressed air to blow away any loose debris. If need be, continue grinding to remove all of the old gasket material. Paint the inside of the channel where the gasket will be placed with the dielectric paint Gliptol. Dielectric paint will be used because there is direct contact with the conductor core. Paint the outside rim around the bottom of the compression system with regular transformer gray paint.